Please sit down. If you're not an usher, please sit down. Good afternoon. Please rise for the Vice Chancellor's procession. The Vice Chancellor's procession is leading here by the Deputy Registrar, Senate Matters, Mrs. Comfort Ehigiato. This procession comprises of the Provost, College of Medical Sciences, the Dean of Postgraduate School, the Dean of Students, Deans of Faculties, Directors of Academic Programs and Institutes, lecturer, principal officers of the university, and the Vice Chancellor. Receiving the Vice Chancellor's procession. National Anthem. Congratulations. Greatest children. Let's make it louder. Greatest children. Thank you very much. Please take your seats. Our phenomenal, highly esteemed, and first-class Vice Chancellor, the very distinguished Professor Lilian Imotia Salami. Other principal, please put your hands together. Thank you very much. Other principal officers of our great university, the provost, deans and directors, professors emeriti, other esteemed professors and erudite scholars here present, top government functionaries, your royal highnesses, greatest university staff and students, invited guests, gentlemen of the press, distinguished ladies and gentlemen. We welcome you heartily to this 320th in the inaugural lecture series of the University of Benin. Today's lecture is to be delivered by an outstanding academic. He is Professor Emmanuel OLUBAYO OGHRE. Please put your hands together for him. Thank you very much. He is a professor of applied mathematics and fellow Mathematical Association of Nigeria. You can put your hands together. Thank you very much. We'll be speaking on a very interesting topic titled Mathematics, the Hidden Thread of Our Universe. May I now respectfully invite the Registrar and Secretary to Council, Mr. Ademola Bubola, as he introduces the Vice Chancellor and the Vice Chancellor's procession. Please put your hands together.
Madam Vice Chancellor, distinguished ladies and gentlemen, I want to plead that you allow me to continue to abide by the protocol as already established by the PRO is standing here, who is representing the PRO of the university very actively. All courtesies duly extended. I'm very pleased today to perform this duty, which is a bountiful one, of presenting to us the #1 citizen on this campus, and of course the #1 Vice Chancellor of the whole of Nigerian university system, and other distinguished provosts, deans, and directors working with the Vice Chancellor of this university. First, let me just mention, for the sake of protocol, because she doesn't really need to be introduced, that's why I'm presenting her. Because every week we come around, we talk about her, and I'm sure many years after, we'll still continue to talk about her. We used to talk about Professor Alele Williams, the first female Vice Chancellor of this university, and after over 30 years, we're having a second female Vice Chancellor. And in the Nigerian university system, the University of Benin is the only university to have produced the second female Vice Chancellor. Until now, there are big universities and small ones that are yet to produce a single female Vice Chancellor. So I think we should give the University of Benin a round of applause. And upon whom this history has fallen is no other person than a former Director General of a national institute, a former Dean and member of Council of this university, and a woman who assumed duty on 2nd December 2019, a woman who has paved the way for the future of this university to be greater than we have all ever imagined. Our dear Vice Chancellor is the Chairman Committee of Vice Chancellors of all Nigerian universities, like I've said, and the Vice President, Association of African Universities. Let's give her a round of applause. And of course, we know that she is also a woman of tradition, apart from very planted in the tradition of Benin. Benin is known for very great culture across this country and even beyond, to the point that they were stealing artifacts, but God is bringing all those artifacts back anyway. So she is also recognized in different communities in Nigeria. She's Organity of Igara land, and recently the EMMANUEL of Ondo Kingdom. That's where I come from. So, distinguished ladies and gentlemen, I present to us Professor Lillian Imatinya Salami. Of course, she's ably supported by very distinguished and eminent professors and even distinguished scholars. First, the Deputy Vice Chancellor Administration, Professor Mrs. Catherine Opawa. The Deputy Vice Chancellor Academic, Professor Ray Ozolwa. The Deputy Vice Chancellor Ekenwa Campus, Professor B.A. Ayinde. The acting bursar of this university, the man who keeps the post very well for the Vice Chancellor and the system, Mr. Gabriel Osadolo. The acting university librarian, the custodian of our books and scholarly publications, Walter Megicine Tioyo, Esquire. The provost of a very reputable College of Medical Sciences, and I choose my word by saying very reputable. When I talk of College of Medical Sciences in this country, University of Benin comes top among the very best. And so the provost of that college, Professor Wilson Sado, the acting dean school of postgraduate studies, Engineer S.A. Aliu, the #1 citizen on campus, a distinguished professor of economics, Professor A.C. Igodaro, Dean Student Affairs. I think the students should clap for him very well. Yes. He's doing a very wonderful job. Don't mind all the, nobody can occupy that position without sitting on very hot seats. We have with us the man I struggle so well to learn his name to pronounce very well, but I still have a little bit of the Chinese version to pronounce. He's the host dean today. He's the host, so I will have to hold him very well. Whether I pronounce your name well or not, rice and stew must be very plenty for everyone, and I can see him really putting up a very beautiful appearance today. The Dean, Faculty of Physical Sciences, Professor E.O. Ayowi. Of course, we have a former Deputy Vice Chancellor Academic and the Dean, Faculty of Agriculture, Professor David Musa Izeko. We have with us the Dean, Faculty of Arts, Professor Constantine Yuka. Today you are the only one wearing your red apparel. Others are appearing well. I'm sure by next, okay, we still have another one. It's okay. We have with us the Dean, School of Basic Clinical Sciences, Professor V.J. Ekanem. We have with us the Dean, School of Basic Medical Sciences, Professor F.O. Agoreyo. We have the representative of the Dean, School of Dentistry, Professor Sonny Okegbeme. We have the Dean of a faculty that is producing Vice Chancellors. And the Dean is the Dean of our own Vice Chancellor. The Dean Faculty of Education, Professor Kingsley Omoregiwa. The Dean Faculty of Engineering, Professor E.A. Ogunjo. The Dean Faculty of Environmental Sciences is being represented here today by Dr. Jeff Nwodo. The Dean Faculty of Law is also represented here today by Professor Bright Bazwaye. The Dean Faculty of Life Sciences is represented here today by Dr. Rachel Okoje. The Dean Faculty of Management Sciences, Professor Enofe. And then we have the representative of the Dean School of Medicine, Professor N.O. Enaruna. We have with us also the representative Faculty of Pharmacy, Professor Loretta Inyage. Please, let's give them a round of applause very well. It's not easy. And because of the inaugural lecturer today, those who are on assignment, they just have to send very distinguished scholars to stand in for them. So that's the more reason why we need to recognize them very well. The Dean's Faculty of Social Sciences is Professor Daniel Tonwe. We have the Director Center for Part-Time Studies, a former Dean of Physical Sciences. He must show his face today because it's coming from his faculty. Professor F.E.U. Osagede. We have with us the Director Center for Distance Learning, Professor Aibovo. And then we have with us the Director Center for Entrepreneurship Development, Professor E.E. Ogiagbe. I'm not sure we have the students appears not to have resumed from, or maybe the long time of staying at home has removed the spark from them. I expect students, particularly from physical sciences, to clap and clap very well. Those in mathematics. Thank you, thank you. Because it's coming from this faculty, you must, if you have seen the way the medicine management have been doing there, it has been so lively. Physical sciences, you must come up and perform. Also, the Vice Chancellor Central is the Director Center for Educational Technology, Professor Hassan Oahena. And we have the Director of IPTT Office, Professor Tito Ogbebo, Anthony Ogbebo. The Director of Tedford Center of Excellence for Aquaculture and Food Technology, Professor Mrs. Ijeoma Obo. The Director Center for Sustainable Development Goals, SDG, Professor Mrs. Ibudu. We have with us the Director of University Quality Assurance Office, Professor Peter Sede. The Director of Investment, the University Advancement and Development Office, Professor Eddie Eragbe. We have with us in the Vice Chancellor's entourage today another very distinguished engineer, this time around a woman, the Director of ADEC, Advanced Digital Engineering Center, Professor Mrs. Orupe. We have with us also the Director, Institute of Child Health, Professor Mrs. Ayebo Sado. You are not seeing them, but like we always know, blessed are those who have not seen, yet believe. So let's claim our blessing today by clapping for them, even if you have not seen them. We have with us the Director's Center for Research and Development, Professor M.A. Bamikole. We have also the Director of External Linkages and Internationalization Office, Professor F.E.O. Inato. We have also another very distinguished scholar, a woman too, who is doing very well, the Director of Student Guidance and Counseling Center, one of the most vibrant of our centers in recent times, Professor Mrs. O.N. Ahie, the Director of General Studies Office, Dr. Osamiro Osagiobare. And we have also the Acting Director, Institute of Education, right there at Ekenwa Campus, Dr. K. Imaswe. And we have also the Acting Director, Institute of Public Administration and Health Services Management, Dr. John Osagai. The Acting Director, Center for Maritime Studies and ICT is Dr. OGHRE is also here. You will pardon me with this name. I have not gone to school to study that one. I will still go back. Of course, we have leading the Vice Chancellor Central today, the Deputy Registrar in charge of Senate Matters, Mrs. C.I. Egiato. Please let's put our hands together for the Vice Chancellor's entourage. Distinguished ladies and gentlemen, you would have observed that the list is endless here because of the personality of the lecturer. Somebody was whispering to us that if your place is not represented today, don't bring any admission requests. We know where that one is coming from, because the controller of the inaugural lecturer today is the one actually in charge of admission. So you have to really watch out and come. So that's why we have this large entourage. And of course, the Vice Chancellor being around today, because it's not often that you see her in our midst. Distinguished ladies and gentlemen, it is my singular honor, very privilege to invite Madam Vice Chancellor to present
Good evening, distinguished ladies and gentlemen. And I want to particularly greet my elders, the retirees. And I often say, if you are not a retired member, I don't know what you are doing on that part of the auditorium. So I want to especially greet you. And I think I can see Professor Binova. Is that the person I'm seeing without a visa? I thought I needed to have a visa. So thank you so very much. And I must continue to thank all the retirees for always supporting us and of course lending us your experiences. And I will soon be crossing over. And I say soon, but that's in another 2 years. So thank you very much. Professor T.K. Aodu, I've often said that we will give you another emeritus. So it will be double emeritus. Thank you very much. And my dear daddy, Professor Elaho, thank you. You're always, attending our inaugural lectures. Thank you so very much. Well, like the registrar said, those of you who are looking for admission and we don't capture you today, please keep your words in your homes, because they are not coming to the University of Benin. But if you know that your words will need admission, then you are most welcome. And I want to greet all the Thank you very much. Distinguished ladies and gentlemen, I welcome you all to the 320th in the inaugural lecture series of the University of Benin. Today's lecture is the 91st to be delivered in my tenure as the Vice Chancellor of this great university, the 6th in the Department of Mathematics, and 21st in the Faculty of Physical Sciences. Ladies and gentlemen, it is my pleasure to introduce our lecturer for today. He is Professor Emmanuel. OLUBAYO, OGHRE. The title of his lecture is Mathematics, the Hidden Thread of the Universe. Professor OGHRE was born on the 30th November 1960 in Kokori, England, to the family of Mr. John Dokeri and Princess Eunice Olamide Akinwale OGHRE. He had his primary education as ABC Primary School Ikire, Osun State, where he obtained the first school leaving certificate in 1972. Attended Fatima College, Ikere from 1973 to 79, where he obtained the West African School Certificate and gained admission into the University of Benin in 1980, and obtained the Bachelor of Science degree in Mathematics Education in 1984. Professor OGHRE undertook the mandatory one-year National Youth Service in Niger State from 1984 to 85, after which he worked as a teacher in Kano State from 1985 to 1987. In 1988, he was employed as a graduate assistant at the Department of Mathematics in the then Bender State University Abraka campus. After obtaining Master of Science degree in Applied Mathematics in 1990 from the University of Benin, he proceeded to obtain his PhD in mathematics majoring in physiological fluid mechanics from Obafemi Awolowo in 1999. Professor OGHRE joined the services of the University of Benin in 1990 as an assistant lecturer in the Department of Mathematics and rose through the ranks to the position of full professor in 2012. Professor OGHRE went on a leave of absence in 2007, where he was appointed the Deputy Director of National Agency for Science and Engineering Infrastructure, NESINA, Federal Ministry of Science and Technology, Abuja, and returned to his teaching profession in 2009. Professor OGHRE has held several administrative positions within and outside the university, such as Assistant Dean, Faculty of Science, Assistant Dean, Faculty of Physical Sciences, Chairman, Parents Teachers Association, Federal Staff School, Benin City, Chairman, Parents Teachers Association, UDSS, Benin City, Chairman, Student Disciplinary Committee, National Secretary General, University of Benin Alumni Association, Chairman, University of Benin Alumni Association, University of Benin Chapter, National Secretary, National Association of Mathematical Physicists, Vice President, Mathematical Association of Nigeria from 2019 till date. Professor OGHRE is a member of professional associations and affiliations, such as where he holds positions as Fellow, Mathematical Association of Nigeria, Fellow, Institute of Planning, Nigeria, Member, Nigerian Mathematical Society, Member, Nigerian Association of Mathematical Physics. Professor OGHRE is also known for community service through various bodies, such as President, Rotary Club of Warri, District Rotary Representative, Rotary District 9140, Secretary, Rotary Club of Oselu, Benin City, 1996 to 98. Professor OGHRE has supervised 3 PhDs and over 40 MS theses. He has co-authored 3 textbooks and has over 50 articles in local, national, and international peer-reviewed journals. He has served as external examiner to several Nigerian universities and the University of Ghana, Legon. He is also a professorial rank assessor for many universities and as accreditation team member for the National Universities Commission. Professor OGHRE has been a principal investigator for research grants and has attracted or attended several local, national, and international seminars and conferences. He is of the Baptist faith and worships at the Covenant Life Baptist Church. He loves traveling and he is known for his philanthropy. He is married to our own dear Professor Mrs. Eki Ogu, a professor of optometry in the university, and the marriage is blessed with 4 wonderful children. Distinguished ladies and gentlemen, it is my singular honor and pleasure to invite Professor EMMANUEL OLUBAYO to deliver his inaugural lecture.
The Vice Chancellor of the University of Benin, Professor Lillian Imoetinya Salami. I want to crave your indulgence to start on existing protocol that has been established earlier on. I feel delighted this evening standing before this distinguished audience to give the 320th in the inaugural lecture series of the University of Benin. First of all, I want to give glory to Almighty God for the grace He has given me to be here tonight presenting this inaugural lecture to this wonderful audience. Isaac Newton said, if I have seen far, it's because I've stood on the shoulder of giants. I will start by remembering all the giants that have made me who I am today. I want to first dedicate this before I go on to the memory of my mother, Princess Eunice Olamide Akinwale OGHRE, who sacrificed everything to ensure I had university education that has made me who I am today. My mentors started very early in life. When I entered secondary school, Fatima College, Ikire, I was very playful. I was very good in mathematics, but my being playful affected my other courses until I got to Form 3 and I met a very wonderful teacher who was my mathematics teacher, and at the same time, he was my form teacher. In my report card, he wrote a promising student. I look at my results. Apart from mathematics, where I will always have the highest, I was seeing 40, 50, and I said, wow, if somebody could believe in me, then I need to believe in myself. And that started the challenge. I took it up. When I got to Form 4 also, another mathematics teacher singled me out because I was always good in mathematics. And that is Mr. Timothy Akombi. He encouraged me. He was also the one that taught us in Form 5. I was representing the state even in every mathematics competition. When I got to the university, I met some wonderful lecturers. The first was my head of department from 200 level to 400 level, Professor Charles Wachiku. He was a complete gentleman and he made mathematics beautiful. And I enjoyed his class. Later, I met late Professor Inyahe, who was very, very wonderful. And he was the one who admitted me to read mathematics, a master's degree in mathematics. And that paved the way to be who I am today. I also want to commend my supervisor, master's degree supervisor, Professor Ezekiel Okeke, who not only supervised my project, but was also the one who recommended me for appointment at Benin State University, Abraka, and later recommended me for appointment to the University of Benin as assistant lecturer. To these people, I say a very, very big thank you, and I say, for those who are resting, may they also continue to rest in peace. The last teacher I also want to comment, and I believe he's here, is Dr. Imohime Alufai. Dr. Alufai taught me in 1981, and it made me to realize that you as a teacher does not have to be very, very excited before your student can follow you. He made mathematics very beautiful, and I say a big thank you to him. Also, when I entered University of Ife for my PhD supervisor, Ebenezakere, was wonderful. Then there is another man who made me who I am today, who taught me how to write and who always advised me. In academics, you keep on writing. If they need 5 and you give them 20, by the time they cancel 10, they will get tired and you will get your promotion. And that is late Professor Ruben Ayeni. Lastly, I also want to thank Professor S. Okoya, who was there to encourage me at the University of Ife. Madam Vice Chancellor, the topic this evening is mathematics, the hidden thread of our universe. Let me look, every one of us are gaily dressed. Can you imagine the thread that runs through your dresses? If it is removed, what happens to it? Everything will fall apart. If mathematics is taken out of existence, definitely we may not have life. Let us remember, God was the first mathematician. God counted the creation in days, which means there was 1, 2, 3 up to 7. Today, I will dare say to every one of us, if there is no mathematics, there may not have been civilization. Before we talk about mathematics as a thread in our universe, let's ask ourselves, apart from being a subject taught in school, what is mathematics? According to the Encyclopedia Britannica 2006, it defines mathematics is the science of structure, order, and relation that has evolved from elementary practices of counting, measuring, and describing the shape of objects. Remember the words there, counting, measuring, and describing the shape of objects. American Heritage Dictionary 2000 describes mathematics as the study of measurement, properties, and the relationship of quantities, and sets using numbers and symbols. As I stand here, if I say I'm going to give a mathematics question to everybody here, some people will not even bother to listen to it. They will say, I don't know mathematics. Yet, I know today, every one of us has done one mathematics or the other. You have bought fuel, you have to pay. You took transport, you have to pay. So many things you do, and we never allow ourselves to be cheated. But once it is said mathematics, people will say, I don't know mathematics. That is the irony of life. So for those who have phobia for mathematics, they also have their intriguing and humorous definition. Bertrand Russell said, mathematics is a subject in which we never know what we are talking about, nor whether what we are saying is true. But we mathematicians, we always say find a solution because we believe solution exists. Charles Darwin on his own said, a mathematician is a blind man in a dark room looking for a black cat that is not there. Will you find it? That shows the averse people have for mathematics. Contemporary definition define mathematics by the past of mathematics, and there are 3 main areas of mathematics. I know some of my colleagues here will insist that there are 2. Where I believe, to the school of thought, I believe there are 3 main areas, and I will take us along. We have pure mathematics, we have applied mathematics, and we have applicable mathematics. The pure mathematics consists of algebra, calculus and analysis, geometry, topology, combinatorics, logic, and number theory. Applied maths involve dynamical system, differential equation, mathematical physics, computational mathematics, information theory and signal processing, and fluid mechanics. Applicable maths in which there is no agreement whether it actually is or not. Some authors prefer to describe it, the applicable mathematics, as a union of new mathematical application. And that is where we have probability and statistics, that's where we have game theory, and that's where we have operation research. Which area of this do I belong? I am an applied mathematician, and my main area in applied mathematics is fluid dynamics. Applied mathematics concern with what we call the mechanics or behavior of fluids, and it has application in many areas. In engineering, mechanical engineering, we use fluid mechanics. In civil engineering, chemical engineering, biomedicals, we use fluid mechanics. Geophysics, we have fluid mechanics. Astrophysics and biology, we have fluid mechanics. Before I talk about fluid mechanics, let's first talk about what is fluid. We all know the difference. We know what we call matter, anything that has mass and occupies space. And there are three. You have the solid, you have the liquid, you have the gases. The ones that flow, that does not have definite volume, we term them all together as a fluid. So anything that flows is fluid. And we all have fluid around us. The air we breathe, the water we use at home, the blood in our body system is fluid. Your cream, your grease, lubricant and so on, all of them are fluid. The soup you cook in your house is also regarded as fluid. And fluid are divided into two parts, because we all know that the way water will flow is quite different from the way oil will flow. The property of fluid that distinguishes one from the other is what we call the viscosity. And different fluids have different viscosity. When a fluid viscosity is zero, that is, it doesn't have viscosity, such a fluid is called an ideal fluid or inviscid fluid. It doesn't exist in reality, and that's why we call it ideal. Fluid with viscosity, we call it real fluid. So we have fluid dynamics divided into two parts. We have fluid static, which is the study of fluid at rest, and we have fluid dynamics, which is the study of effect of forces on fluid in motion. Isaac Newton is the father of mechanics. He started mechanics, and he propounded three laws. And the first one says, every object continues in state of rest or uniform motion, except it is acted upon by an impressed force. The second one says force is directly proportional to the rate of change of momentum. And the third one says action and reaction are equal and opposite. The second law gives us three conservation laws: conservation of mass, conservation of momentum, and conservation of energy. This conservation law, the first conservation law, which is conservation of mass, leads us to the equation that we call continuity equation. And what does it say? It says, the equation says, generally we always say matter is neither created nor destroyed. That's a simple way of saying it. We in mathematics, we say rate of mass accumulation is equal to rate of mass in minus rate of mass out. For example, if you have 50 liters of oil and 20 goes out, what is accumulated will be what? 30. So that is what is. And when you look at it, that is the continuity equation. The second law also leads us. Don't worry, we are going to get there. We are going to get there. I will make every one of us mathematicians today. Now, the second law, which is conservation of momentum, leads us to the equation we have above. And this is what we call the Navier-Stokes equation. And this equation solves all problems in fluid. Everything that flows, this is the equation that solves it, and you can always use it. For us not to be... From this equation that we have, there are many things that we can deduce. For example, we can deduce when you fetch water and it's flowing into a bucket, you can deduce at any time the volume of liquid you are going to have. The equation also leads us to Again-Poirier's equation that medical doctors, physiologists use in calculating the volume of blood that flows in our body. So the equation should not be something that will frighten us, but should be something that we should be very, very happy with. It was propounded as far back as 1822. Now, my topic says mathematics, the hidden thread in our universe. I will take us through some example that shows us that every one of us, we are mathematicians to various degrees because we carry out mathematics one way or the other. We do budgeting, do we not? Don't we calculate interest when you put your money in bank? If you are cheated with your tax, will you not know? So we use mathematics in our financial management. Without mathematics, things might be. And many of us, we subscribe to the pension fund. We are looking forward to, at the end of our retirement, you get a lump sum. Let's say, for example, you have 20 million as your lump sum. And the question there is always that fear. This money I have, will it be enough for me till I die? How do you know? All you need to do is to turn to a mathematician and they will formulate an equation for you. For example, what I've taken here is assuming you put your 20 million in a bank and the prevailing interest is 10%, which is 0.1. And you are giving yourself 250,000 every month, which means in a year you will be spending 3 million. When you put it in equation, you will find out that your 20 million will take you 23 years before it can be exhausted. So we use mathematics in our financial management. When we meet our doctors or we meet a pharmacist, they prescribe drug for you and they will tell you 2 tablets 3 times a day, it can be once a day, it can be whatever they give you. What they have taken into consideration is to be able to build the concentration of that drug in your body up to the level that it reach a particular level and it can take care of that disease. And the concentration will be built. We can use equation to determine the concentration. And that is why it is very, very advisable when doctor says take it 8 hourly. When you break it, you are reducing the level to which the concentration in your body will reach. And when we say, oh, I took this drug, it didn't work, the question there is that, have you followed your doctor's prescription? So mathematics is also used for our safety. We can see this building here, how it stands. Many of us came here, we sat on the chair we sat on. Some people must have taken into consideration the strain and the stress on the chair to be able to build it in structural engineering or whatever, to be able to build it such that we can walk in anywhere and we have no fear. In designing our road traffic system, by analyzing traffic flow, engineer can design roadways and control system. We know our traffic lights, some carry 30 seconds, some 60 seconds, some 90 seconds. Before these are done, they must have used mathematics to be able to determine the flow, determine the speed, before all these things are put into practice. So we use mathematics in designing our road. When you board a flight, before that flight will take off, mathematics is used. They calculate the maximum takeoff weight, the maximum landing weight, and they were able to also use mathematics to calculate aircraft load, which is the ratio of the lift to the weight of the plane. So mathematics is also used in aviation. In environmental preservation, we model climate change, and we are able to use climate change modeling to determine climate pattern and predict future trend. And from there, you can go ahead and advise government on their policy. We also talk about population dynamics. Through models that we use, we also find the prey predators. For example, those people who do fishery. You know, some fishes, some eat the other. You should be able to use mathematics to be able to determine at what time to harvest, such that the bigger ones will not finish the smaller ones. Mathematics is also used in conservation effort by predicting population trends and impact of environmental factors on these areas like pollutions and so on. We also use mathematics there. Mathematics is also used in epidemiology. We can model and track the spread of disease and be able to advise government. We also talk about control. We introduce control into our models and be able to determine both resource and other waste management. When we go to school and we learn mathematics, why is mathematics very, very important? Mathematics help you to develop critical thinking, which is applicable in every decision-making process. Secondly, when you learn mathematics, you also learn to break complex problems into smaller particles, one by one, step by step. Mathematics also help us in logical reasoning, which is very essential for making our decisions. So when they say prove the angle in a triangle, what they are teaching you is logical reasoning. Mathematics also enables students to analyze and interpret data. Not too long ago, I was reading about somebody talk about data. Data is meaningless to anybody until you are able to interpret it. And data, in today's world, it is data that controls us. Understanding statistics also allows students to draw meaningful conclusions from data. Statistical analysis is widely used in our research and businesses. I have seen many people coming here and presenting their inaugural lecture, and many of them use mathematics to explain some of their areas, and I just see mathematicians. Yes, it is the hidden treasure that we never valued. One area of mathematics, Madam Vice Chancellor, that is very applicable and very useful to us is projectile motion. Projectile, when you throw an object up, it comes straight down. But when you throw an object at an angle, it has this shape, and that's what we call the trajectory of the projectile. From this shape we have here, there are many things we can calculate. We can calculate the range, the distance from one point to the other. You can calculate where the particle will be at any time t. You can calculate the maximum height it can go. And this projectile is used in sport. A basketballer who wants to throw a ball to enter the net must be able to know at what angle he should throw. When Ronaldo kicks a ball, he has a goalpost before him. He will have to calculate, he will need to know, he will have practiced over time to know at what angle to kick the ball, the forces he needs to put into it to ensure the ball does not go over the net, and he will be able to have a score. Mathematics is also used in military warfare, just as I've said with projectile. You can use it to determine, to be able to bomb an enemy point. You do not need to go to a place before you. All you just need to do is to be able to have an idea of the distance from that place to where you are. So projectile help us in targeting. It also helps us in resource management, because if you can target your enemy position, you will not need to waste your armory on it. You will just go straight and you bomb it. It also helps in strategic planning. Our farmers that are here, mathematics is very, very useful. And if you have not been inviting a mathematician to advise you, this might be the time you need to. We use linear programming to create mathematical system of equation and inequality, to be able to make decision on which crop to plant in a specific field. You use mathematics to to determine pest control, you use mathematics to be able to talk about population growth rate, pesticide population growth rate. We also use mathematics to do soil analysis. We also use mathematics to be able to determine the yield a particular crop will give you when you apply your fertilizer. You know, when you apply fertilizer, you intend to have a gain in your yield. But do you keep on applying so that it can increase? No. It has a maximum point to which it must reach to be able to determine what to give you maximum yield. Any other thing you apply after that will just be a waste. We have fashion designers that have designed many of our dresses today. Do they use mathematics? The answer is yes. Apart from pricing, discounting, keeping inventory, a fashion designer needs to know how to design patterns. You need to know how to take the symmetry both of the person that is going to wear your dress and the symmetry of the pattern you want to give the person. So mathematics is also used in fashion designing. Madam Vice Chancellor, I know in the kitchen also, we measure the quantity of salt we are going to add into the soup. In crime detection, forensic detection of crime, there was a case where a murder was committed and a policeman who had mathematical background was invited. There were many people there that he could arrest, but what he did was he looked at the body, took the temperature of the body, took the temperature of the environment. He went away. After some time he came back again. He took the temperature of the body and he went ahead and used mathematics using his law of cooling. The rate of change of the temperature will be difference in the temperature of the body and difference in the temperature of the environment. And he was able to determine the time the crime was committed. And once you determine the time of crime committed, you might be able to pin the suspects down. Mathematics is also used in forensic practices. Every one of us know that mathematics is in engineering. And hardly will there be engineering without mathematics. Structural engineers use mathematics to be able to determine the structure, to calculate how the structure can withstand load without failure. Electrical engineers use mathematics in analyzing and designing electrical circuit system. Mechanical engineers use mathematics to be able to analyze force, motion, and energy in any mechanical system. In civil engineering, they use mathematics because when you want to build a bridge, first you need to determine, should it be rectangular shape, should it be cylindrical shape. When you are taking to cylindrical shape, you have to use algebraics, which I mentioned earlier on, to be able to determine the volume of water so that you can determine the radius of the cylinder you are going to use. Mathematics is always there. If mathematics is everywhere, where have I contributed? What have I done? Any problem in reality, any problem can be modeled by system of equation or differential equation. We all know that blood flows in our body. The blood that flows in our body contains red blood cells. And these red blood cells carries oxygen and nutrients from one part of the body to the other. The arteries through which it flows is also flexible. However, we have the red blood cell is oval in shape and should be able to move from one point to the other. However, there are some patients that have the sickle cell disease. The red blood cell at a time may be sickled, in which case it is not oval. Or there are times it also becomes rigid. And what does it do? When it becomes rigid, the movement is impaired. It's not as smooth as it should be. We use mathematics equation to be able to model the movement of those red blood cells. And we find out that when the viscosity increases, OGHRE and OGHRE 2017 investigated the effect of this increase in viscosity on the flow of blood in our arteries. And what we find out, mathematically, we find that this solution, this equation, contains what we call discontinuity. We also call it shock. The doctors will call it the patient is having crisis because the blood is not flowing the way it should flow. So the nutrients will not be reaching some parts. What you may have there is that there might be increase in temperature in that particular position. There might be a situation where the other part, there will be swelling. And this is what we call crisis. Now, OGHRE and OGHRE in 1998, now rather than taking our blood as a viscous blood, we took the blood as viscoelastic. Viscoelastic means the blood is viscous, at the same time is elastic. So you have two properties. And what we were able to find out that in the equation that we have there, the discontinuity was destroyed. The equation that we got was a smooth equation. And the implication of this, if our medical doctors can find any particular drug that you will inject into a sickle cell patient such that the blood becomes viscoelastic, then the crisis might be very, very well reduced and managed. At one time or the other, many of us may have had the opportunity of boarding a plane. When the plane is about taking off, there are some sensations we experience. Either you start hearing noise in your ear, some you have palpitation, your heart will be beating fast, some have headache, some have cramp in their tummy. Then when they are in sport, also those people that do gymnastics, they also experience such a thing. Because your body is being subjected to high velocity under gravity. And what we did was to do a two-dimensional problem of the blood flow in the arteries. And we call this leak back flow. Ayeni, OGHRE, and others in 2002 studied this. The people who do Ibaboleyi, when they turn and turn and turn, you will see their eyes will be turning. And we find that what happens there is that the red blood cell accumulates at the arteries, leaving the white blood cell, the plasma, behind. And that is what causes all the discomfort that we feel. The only lock there is that because it's not for a long time, after some time our body recovers again and we feel comfortable. We are all afraid of fire and we pray that we never see fire outbreak. But we know that there are situations where we need combustion. So we did, and this is what we call piloted ignition of fire. When you wake up in the morning or at any time, for you to start your car, there must be ignition. If the engine does not ignite, it will never move. In turbine another engine, you need combustion. OGHRE and Ayeni 2003 use this equation that we have here, which is conservation of mass and energy, to be able to study piloted ignition of fire. And we were able to find the profile of the temperature that will lead us to finding the ignition point of the equation. The ignition point is the point where the fire starts. So that when there is a fire in anywhere, you invite a mathematician, he can draw the profile looking at all the materials that are there to be able to determine where the fire starts. And once you find where the fire starts, you might be able to prevent it another time. Then when we are constructing any of our structures, we also take this into consideration. OGHRE and Ayeni 2003. I said earlier on that mathematics is used for the study in epidemiology. OGHRE and OGHRE 2012 did what we call an SIR model of cholera. We know cholera is an acute intestinal that you get through a particular bacteria which we call Vibrio cholerae bacterium. Now, susceptible means people who are exposed to a particular disease. Once you catch that disease, you go into a group that you call the infected. Then the removed group can be either you are cured or the person passes on. So you have SIR. In our SIR, we introduce what we call the growth term, which comes from the environment. And we have this equation which we just presented here. Because we are mathematicians, we definitely have to see some equations. And we have the model represented by their equation. And we were able to establish that any susceptible human population exposed to a permanent environmental reservoir of toxigenic V. cholerae will be prone to cholera outbreak. And that is why the recent cholera that started in Lagos started from the slum of Lagos. The magnitude of the problem in terms of public health will vary according to the probability of secondary transmission. If secondary transmission is high, definitely the disease will always be high. So in community with good sanitation, cholera will show up only as occasional primary case without secondary transmission. In poor community, on the other hand, there will always be endemism, which will result from close contact between susceptible individual and the source of contamination. OGHRE and Inaugural 2014 also did work on this cholera again, but this time around we talk about environmental effects, environmental consideration, the variation, seasonal variations, the variation in the season. We know we have the dry season and our wet season, rainy season. And what we find out is that there is a particular strain of cholera that is more virulent during our rainy season, and that is what we do. When we do epidemiology studies, what we try to find is called the reproduction number. And this reproduction number, when it is higher than 1, then the disease will be prevalent, the disease will be endemic in that environment. When it is less than 1, it is always that the disease can die out. For this one here, there are situations where the disease can die out, and there are situations where the disease can just remain endemic in that environment. We also did a work on measles. OGHRE and ACO presented the one we call susceptible, exposed, infected, and the removed case. I've already explained the SIR. The exposed case for this measles disease is the situation where you have somebody has been exposed to that infection and the person has caught it but does not manifest any effect outwardly. However, it's a carrier, which means because it's a carrier, it can also spread the disease. And they are more dangerous than the people infected. The people infected, you know you have to prescribe, you can cure. But the exposed, you don't know that disease is there because they don't manifest anything. And that is why we did this particular result. So we find out the condition that will be precedent for the disease to die out. We also did a work on malaria. OGHRE and Ogedebe 2011. I don't know whether Mr. Ogedebe is here. He was my MSc student. We investigated what we call the vector host. Every one of us know that mosquito is the one that spreads malaria. Yes, that is our assumption. However, which means when a mosquito bites you, we believe it will transmit the parasite into our system and we become infected. However, a newly born mosquito or a mosquito that has not had any disease, when you buy somebody that's gotten the disease, what happens? You also transmit the disease back to the mosquito. So what we call the host and the vector, the human being can be a host this time around, and at another time you become the vector at another time. So there is a vicious circle that goes around. So this what try to study, is there any way we can break this vicious circle such that we will not have? But what we find out is that the reproduction ratio is always greater than 1, which means mosquito will always be endemic in our environment. We look at the government policy on health care, National Health Insurance Scheme, and I know many of us subscribe to it. The assumption of the health scheme is that once you are insured, that means all the problem, your health problem is gone. However, there are some other charges that are not taken care of in the scheme, yet they are very important, especially this period of time when the cost of transportation has become very, very high. If you are at a care dolo and your primary health care center is at New Benin, and your primary health care is at New Benin, what we will find out there is that you may at times prefer to buy over-the-counter drug than having to transport yourself to go to New Benin. So we advise government to be able to site healthcare centers in a proximal environment where people are living. We do some other work on plant biology, OGHRE and EMMANUEL for 2012. And what we try to do in this to be able to study how water moves, because every plant needs water. How water moves from the soil to the stem to get to the branches. And we study it and we are able to make our finding. We also model groundwater. Groundwater are water we have under the ground in our pores and fractals. And what we did is to model this groundwater in a confined aquifer. Confined aquifer is a geological unit that can store water and transmit. The system we have presently there is that once you have acquired a land 100 by 100, you put your building on one corner, you go to another corner and you sink your borehole. What we did is to be able to find the aquifer parameters that you will need for you to be able to have your borehole, and you will be sure that your borehole can last a longer time. My ongoing research involves the study on typhoid fever. Every one of us, one time or the other, you must have heard people say, I have malaria, I have typhoid. I have malaria, I have typhoid. This work is in collaboration with 4 other researchers, Dr. Chris Nwenjiwe of Uniben Clinic, Dr. Olowu, a senior lecturer in mathematics department, Dr. Ndubuisi Mokogu of University of Benin Teaching Hospital, and Dr. Mrs. Chigozie Acha, a associate professor of statistics from Michael Okpara University. And in this work, we were able to get a fund from TED Fund for this work. It is still ongoing. What we are trying to do is to be able to use statistical analysis to determine the prevalence. How common is this typhoid fever in our environment? We will also use it to test the knowledge of people about typhoid fever. How much awareness do we have about typhoid fever? Do we even know what causes typhoid fever? This is what this study is, and I pray that by the time we finish, it will be very relevant to our community. Madam Vice Chancellor, my distinguished audience, mathematics is everywhere, whatever your vocation is. Every one of us use mathematics. A carpenter needs knowledge of mathematics, a barber, and all economics. Tell me your area and I will tell you the quantity of mathematics, that the amount of mathematics you need. Mathematics makes the world beautiful, and mathematics is life. Because it is hidden, we never value it. Every one of us do it either directly or indirectly. My recommendation, because mathematics is fundamental cornerstone of human knowledge and progress, it plays a pivotal role in various aspects of our lives and drive advancement across multiple fields. I therefore want to recommend as follows. 1, mathematics should be made compulsory for all students up to 300 level of our education in the tertiary institution. 2, interdisciplinary research of mathematics and other disciplines should be encouraged through sponsorship. 3, mathematics lecturers should pay more attention to the application of mathematics in our daily life than the theory of mathematics. Lastly, government should pay more attention to research findings in mathematics. Conclusion. Looking ahead, the role of mathematics is set to become even more critical as it continues to evolve and intersect with other disciplines. Artificial intelligence, machine learning, quantum computing are at the forefront of technological advancement, and all this made mathematics. Also, we are in a world of explosion of data, and these data demand sophisticated mathematical techniques to be able to analyze and interpret the information. Mathematics possibilities are as infinite as the universe. It moves through every aspect of our existence. Let us consciously embrace mathematics. My acknowledgement. Madam Vice Chancellor Ma, I want to most especially thank you personally on behalf of my own family. I say a very, very thank you because you have been a wonderful mother. Your coming to the University of Benin has brought so much progress, and your work speaks for you. Thank you very much. God will continue to uphold you. I know you have a team, the ever-smiling Professor Catherine. Thank you very much. Your door is always open to me. My dear friend, Ray Ozolua, DVC Academics, thank you very much. DVC Ekawa, my brother Guillaume Ayinde, thank you very much for always being there for me. I will not forget my other brother too, the registrar of the university, a very unassuming man. I say a very big thank you to you. At this moment, I want to recognize and thank my wife, Professor Mrs. Eki OGHRE. She has been a great pillar, she has been a great support. Thank you very much for being there. To my wonderful children, Ogene Rona OGHRE, thank you, you are there, thank you. Ogene Kovie, the husband of Ogene Kovie, here Ogene Kovie is outside the country, but the husband is here. Dr. Ofuane, please stand up. Let them see you, let them see you. Stand up, please, just wave to the audience. Ifeanyi Ofuane. Ovietobore is there, and Elo Ogene. You all have been wonderful children. I say a very big thank you to you. I want to thank my immediate brothers and sisters. My elder sister Kemi OGHRE, Kemi Adeyemo is here. Shegun is here. Kayode must be somewhere in the audience. I say thank you to every one of you. My other last younger sister is outside the country. I believe she's watching us. My other brothers, Shegun, Tunde, Sunday, you are all recognized, and I want to say a very big thank you for being there for me. I appreciate every one of you. I thank my OGHRE family, represented here by my cousin Fidelis OGHRE. Thank you. God will continue to uphold you. I will not forget my mother's family, Oyedeji family, and I say a big thank you. Another family I want to recognize this evening are the Obasoha families. My mother-in-law is here. Thank you for, you have always been our pillar, and I say God will continue to increase your joy. Thank you for being there for us. Professor Emmanuel Obasoha, thank you very much. I appreciate your coming tonight. Thank you. Professor Austin Obasoha, you have always been our advisor. So thank you. God bless you. I appreciate all you have done for us. I also want to especially recognize my in-law, the Ofuanis. I don't know whether Professor Ofuani and Professor Mrs. Ofuani are here. I appreciate and recognize you. Department of Mathematics, Department of Statistics, Department of Computer Science, all the professors in this department, I regard those three departments as one because we have always been one. Mathematics is the only department in this university that has given birth to two other departments. So all mathematicians, I say thank you very much. Physics department, chemistry department, we are all one in physical science, and geology department, we are all one, and I say a very, very big thank you to all of you. That will not permit you to start mentioning everyone one by one, but your name is already in the booklet. My associate department, Department of Optometry, where my wife is the lecturer. I say thank you to you. My clubs that are here, Kokori Elite Club, I want to especially recognize. President, please wave your hand. Kokori Elite Club. My Mathematical Association, National Association of Mathematics, Professor Aso, thank you very much. Mathematical Association of Nigeria, thank you very much. Club O20, thank you for being here. Rotary Club, thank you for being here. All my friends in the universities, I say a big thank you. I recognize two of my fathers here, Professor Musa Egafona. Professor Egafona and Professor Mr. Egafona, thank you very much for bringing me up. Professor Felix Okeme, I say a very big thank you here. Thank you very much. Madam Vice Chancellor, it has been a privilege. Thank you.
Please celebrate our lecturer. Celebrate our lecturer. That was a mathematical lecture. Thank you very much, sir. If you don't understand the mathematics that was on the screen, you can meet him after the lecture with your calculator and your notebook. Thank you very much. Please be seated. May I now respectfully invite the #1 Vice Chancellor in Nigeria, Professor Lilian Imotinyi Salami, to give a recap of the lecture.
Distinguished ladies and gentlemen, for the first time I'm getting to know that mathematicians are Bobo Nishe. So they touch everything and everywhere. When we were growing up, for those of you not dyeing your hair, if you were a mathematician, you had to have crazy hair because mathematicians were crazy people. But these days, you can tell Professor OGHRE's own is clear and clean. So something must be going on. Distinguished ladies and gentlemen, I just want to quickly recap here by adding my voice to that of the lecturer by actually saying that the basics of addition, subtraction, multiplication, and division are the building blocks of scientific knowledge. Without a solid grasp of these fundamentals, further learning in science and other fields will be mere illusion. Professor OGHRE recommended, among others, that mathematics should be made compulsory for all students up to 300 level of education in tertiary education. And I want to add on my own, taking permission from ASU, that mathematicians should be paid higher than every other lecturer in the university.
Please celebrate our Vice Chancellor, Professor Lilian Salami. The Vice Chancellor will now decorate our inaugural lecturer and invite his immediate family to come up stage to support him as he gets decorated. Prof. Ma, please come up stage. Wife, children, immediate family, immediate brother, immediate sister, please come up stage to support him. Thank you very much. Thank you very much. While that is going on, please put your hands together for the spouse of our lecturer, the chairman, University Admission Board, Professor Mrs. Keki OGHRE. Please put your hands together. Also put your hands together for his children, Ovietobori OGHRE, Ogene Rona OGHRE, Elogene OGHRE, Dr. Ifai of One. Please put your hands together. Also celebrate the parents-in-law of our lecturer, Professor and Mrs. Iyeporeti Ewama. Please put your hands together. Thank you very much. Please also celebrate some family members of our lecturer, OGHRE Moses, Mrs. Adebayo Kemi, Mrs. Obasoha, OGHRE Daniel Fidelis, Chief Honorable Sonny Emiyese. Please put your hands together. All other family members, we celebrate you. Please join me, welcome former CMD UBTA, Professor Austin Obasoha. We welcome you, sir. Please put your hands together. Also join me, welcome Emeritus Professor Raymond Eliho. You're welcome, sir. Also join me, welcome Emeritus Professor T.O.K. Awudu. Please put your hands together for him. Thank you very much. Please put your hands together as well for Professor and Deacon Patrick Binovia. You're welcome. Professor Maureen Ebon, we welcome you. Professor Mrs. Kukore Egafuna, you're also welcome. Former Deputy Vice Chancellor Ekewan Campus, Professor Joel Agbolagba, you're welcome. Former Deputy Vice Chancellor Academic Professor Emmanuel OLUBAYO, you're welcome. Please put your hands together. Please put your hands together. Thank you very much. Post-UTME Chairman, Professor Mrs. Omoege, we welcome you. Former Provost College of Education, Warri, Professor Mrs. Edema, you're welcome. President, Nigerian Association of Mathematical and Physics, Professor Vincent Aso, you're welcome. Treasurer of the same association, Nigerian Association of Mathematical Physics, Professor Amos Pupola, you're welcome. Please put your hands together. Please put your hands together. Thank you very much. Dr. Ruben and Professor Mrs. Adesu Osao, you're welcome. Former Dean of Faculty of Agriculture, Benson Idahosa University, we welcome you. Professor Eric Omogba, you're welcome. Professor Ademola Adeyeku, you're welcome. Professor Godfrey Ariave, you're welcome. Please put your hands together. Past Presidents, Uniben Alumni Association Worldwide Chief Macaulay Omo Azubene, you're welcome. Acting Director, Alumni Relations, Dr. Stephen Obeki, you're welcome. Please put your hands together. Professor Egosase Iyamu, you're welcome. ASU Secretary, Dr. Success Abusoma, you're welcome. Professor Jennifer Ebegbe, you're welcome. Professor Faustina Idu, you're welcome. Please put your hands together. We welcome members of Kokori Elite Club, Warri, led by the President, Mr. Clement Odufocha, you're welcome. Please put your hands together for them. All members of Rotary Club of Nigeria, you're welcome. The jogging family, you are welcome. Please put your hands together. Thank you very much, distinguished ladies and gentlemen. That's how we conclude the 320th in the inaugural lecture series of the University of Benin. Please put your hands together. Please rise for the Uniben anthem and the national anthem. National anthem. Please remain standing as the Vice Chancellor and the Vice Chancellor's procession leaves the auditorium.